This video will cover how to combine the commands for descriptive statistics along with logical operators that will enable you to do subgroup analysis in R. Before proceeding, the first thing that's really worth emphasizing is that you need to be relatively comfortable with how to use logical operators, and you also need to be relatively comfortable with the commands for descriptive statistics. So if you're not quite there yet, it's a really good idea to go back and review those topics before you watch and work through this video. All right, so if we go to our studio and let's just load the general social survey that we've been using through these tutorials, the GSS for 2016. And so the first thing that we're going to do, and this is an optional step, but is usually a good idea, is to check the descriptive statistics for what we're going to be working on. So let's say, for example, that we wanted to take this variable in the GSS called hours1, which is the number of hours the respondent worked in the last week. And then let's say we wanted to calculate means by the sex of the respondent. So I'll start by just using table $$ sex, and that will tell me the specific value labels that are attached to that factor variable, right? So we see male and female, all uppercase. If you want, you can also look at the results for hours1, which is the hours worked variable. And there we go, right? So we can see that hours1 is interval ratio, so it's appropriate to calculate the mean for it. All right, so let's first just get the mean for hours1 before adding any of the subgroup complexity. So you just type mean, open up parentheses, GSS $hours1, and then we'll deal with the missing right away. na.rm equals true. So we have that and we can run it, and then we'll see that on average, people in the GSS work around 40.91 hours a week. But now let's say that we wanted to know whether or not men and women in the GSS work comparable hours. So the first thing that we're going to do is start with some square brackets, and that's because really the easiest approach to these subgroup calculations is working from the inside of your commands all the way out. So the first thing that we're going to do inside those square brackets is use GSS $sex, logical equals, so double equal sign, and then let's put in male. So this will eventually return the mean for men. So that's all that we really need to do in terms of logical indexing. So then now let's go and start building up the rest of the command. We know that we want hours1, so I'm going to just start typing that right here, GSS $hours1. And so now what we've got is that hours1 variable followed by all of the cases where sex is going to come back as true. And so ultimately what this will do is pull only the male cases for hours1. And if we just ran this part of it, we're going to just get a bunch of results rather than the statistic that we're after, right? So those are all the values that we want. And we just want to take the average of those. And so really from there, all that you need to do is just expand your command a bit more. So type mean, start parentheses, go to the end, and then put na.rm equals true, close parentheses, and then if you run it, you'll see that we get a mean for men of around 44 hours. Okay, that's one side of it. So then let's go see how this would look for women. Again, I'm going to start with some square brackets and then type GSS $sex logical equals female, right? So this is pretty similar to what I had before, except now I'm just pulling the women from the GSS as before, GSS $hours1, because that's the variable that we're ultimately interested in. And then I'm going to just go and expand that by adding the mean command. So the mean for hours1 for only women, and then I'm going to just make sure that I catch the missing by removing them. And so here you can just highlight and run that command, and you'll see that there's actually a fairly substantial gap, right? So women in the GSS work approximately 38 hours, men work approximately 44 hours. So there is some sort of a distinction there. This example has really just focused on stratifying by one group, by sex, but we can actually build up these commands to make them as complex as we want. So now let's say that we also wanted to distinguish not just by sex, but also by age. And so just like before, we're going to start in with our square brackets, and then I'm going to put in GSS $sex double equals, in quotes, male, just like we saw in that first frequency distribution. And now let's say that we just wanted to have the men that were over 40. Well, you can just do an and, the logical and, GSS $age is greater than or equal to 40. Right? So now we have two logical conditions. We want only the cases where it's true that they're both male and that their age is either equal to or greater than 40. So from there, it's really just a matter of going back and filling in the rest of the information. So we could type GSS $hours1 and then go in and expand that to include the mean. Just like always, na.rm equals true, so we don't have to deal with problems caused by the missing. And now if I highlight that line and I run it, you can see that there's actually not much of a difference between men generally and men that are over 40. And if you wanted to expand that again for women, I'm going to just copy and paste this line and then go in here and add in female instead of male. And now if I run this, you can see that again, there's actually not all that much of a difference. That's okay, because this is really just an example, but it hopefully will illustrate to you that you can use arbitrary combinations of variables to pull very specific subgroups. And ultimately, that's what you're going to be doing when you're engaging in inferential statistics.